Hey girls, I'm going to resume where we left off with redox reactions. Your last homework was to identify what was being oxidised and what was being reduced in equations. I'll correct that when I get back. I just want to continue on with something called oxidation numbers. Oxidation numbers are used ultimately to balance chemical equations, but first of all we need to know what they are. So there's your formal definition is that an oxidation number is a charge that an atom appears to have when electrons are distributed according to certain rules. Now, the following rules you'll get in your textbook. Keep them open beside you as we go through these. I've got a summary of them on the next couple of slides. So, oxidation numbers. The oxidation state of an atom in uncombined elements is 0. So, an uncharged molecule or an atom on its own will have an oxidation state of 0. The oxidation state of a monoatomic ion is the charge on that ion. So, for example, sodium's in group 1. When it becomes an ion, it has a charge of +1. That means its oxidation state is +1. Beryllium, likewise, is in group 2. When it becomes charged, it loses 2 electrons, so it has a charge of +2. That then is its oxidation number. In covalent compounds with non-metals, hydrogen always has an oxidation number of +1. But if it's bonded to a metal, then it's -1. That won't happen very often. It's mostly +1 for us. Oxygen has an oxidation state of -2. That only changes if it's bonded as a peroxide ion. In that case, then it has an oxidation state of -1. Hydrogen here, as you can see, hydrogen will always be +1. You've got 2 of them +2, so each oxygen has to be -1. Oxidation numbers for an ionic species, so any ion has a charge, and that means its oxidation state of that ion is the charge on that ion. And it helps you then work out the individual oxidation states of the atoms present. The oxidation state of chlorine is always -1, except if it's bonded to something called a more electronegative element. So electronegativity is something I'll discuss with you next week. But just for now, take it that chlorine is always -1 unless it's bonded to oxygen or fluorine, in which case that changes. And for a compound, the sum of the oxidation numbers is 0. So this is just a short summary of the rules. You can take a shot of this, Photoshop of this, and then just put this into your notebooks. So group 1 metals are always +1, group 2 metals are always +2, oxygen is always -2 unless it's in a peroxide form. Hydrogen, excuse me, bless me. Hydrogen is always +1, except if it's bonded to a metal, then it's -1. Fluorine is always -1, and chlorine is usually -1 unless it's bonded to oxygen or fluorine. Okay, so now what follows is practice assigning oxidation numbers. So I'm going to do this on a sheet. I'm going to finish this video clip now, and I'm going to do the actual examples on a following video clip. So watch that afterwards.